Hey guys, this is Manish and welcome to my YouTube channel. So in this video, I'll be talking about Quicksort. So how Quicksort actually works. I'll later show you the algorithm that how Quicksort works. Okay. So before proceeding, please do subscribe to my channel for more contents regarding placement and interview preparation because I'll be posting a regular content regarding this topic into my YouTube channel. Okay. So stay tuned to my channel for more contents and please do subscribe. Okay. So let's look at Quicksort, how it works. Okay. It is based on the divide and conquer strategy, which means you have to devise a method in order to divide the array in two parts. Okay. And then solve each part recursively using the same divide and conquer strategy. Okay. So let's see how it works, and later you will understand how divide and conquer method is implemented on this Quicksort. Okay. So let's say this is our array. Okay. First of all, we need to divide the array in two parts so that the smaller half would be residing on the left side, bigger half will be residing on the right side. Okay. Now, how can we devise that? It is not guaranteed that the left side or the right side should be sorted, but the smaller or larger element will move onto each corresponding side. Okay. So first we need to find a pivot element. Okay. So there are a lot of techniques to find pivot element. We can either take this first element as a pivot, or take this last element as a pivot, or take some middle element as a pivot, or take some random element as a pivot. Okay, so for better understanding, I'm taking the last element as pivot. Okay, let's call it as P. What I can do, I can partition the whole array in terms of this pivot element. Okay, so one partition means that pivot element should reside on its corresponding correct places, and the other part that was smaller than the pivot element will reside on the left side, and the other part that is bigger than the pivot element will reside on the right side of the pivot. Okay, the logic is usually we take two pointers I and j. So I'll be pointing to the left of leftmost index at initially. So I'll just pointing at this position. This is I, and j will be pointing to the first element, and it will go up to the second last element, which means this element. Okay, because this is already pivot element that was previously set. Now, how can we do that? Using two rules. Okay, so here are the 2 points. So the partition method of a Quicksort works based on this one condition, and it will subsequently do this step. Okay, so just follow this. If this element, which means array of j less than pivot, okay, which means P here, so 10 is less than 75, so we'll increment I, so I will be pointing to this point, okay, and we'll swap array I and array j. So in this case, both are pointing to the same point, so the swap will occur and 10 will remain at this position. Okay. Now we increment j. Okay. So j will be pointing to this point. So this is j. Now, if array of j less than p, then only we do this step. If in this case 85 is greater than p, so we'll increment j. We'll do nothing here. Okay. So j is now pointing to this point. Okay. Now 25 is certainly less than 75. So we'll increment I. So I will be pointing here, and we'll be swapping array of I and array of j. Okay. So in this case, that will be 10, that will be 25, it will be 85. Now the remaining will be same. Okay. Now we increment further j. So j is here and I is at this position. Okay. Now 95 is not less than 75, so we'll do nothing. We'll increment j. J will be pointing here. Now 35 is less than 75, so we'll increment I and swap array of I and array of j, which means these two elements will be swapped. So what will be the result? So this will be the result. Okay, 35 will come here, 85 will go there. Okay, now j will be pointing to this position and I was at this position. Okay, 60 is certainly less than 75, so we'll increment I and we'll swap these two elements. Okay, Okay, so this will be happening. Now we have reached up to this point, so we'll not further move. So let's look at this. What is this sort of value looks like? These are already less than this pivot element. 10, 25, 35, 60 are already less than this pivot element, okay? And now look at this part, 85 and 90. This is already bigger than this pivot element. So in this one partition method, we are very much sure that this element will obviously placed at this position. Okay, if I place 75 at this position, we'll find that the array, the left hand side of 75 is already less than the 75, and the right hand side of 75 will already bigger than 75. Okay, so we are very much sure using this partition method. This is the first phase of the quicksort, and this is the very important phase, the partition method. Okay, now how to place 75 into this place? We'll just swap these two elements. Okay, previously our I was at this position, so we'll be incrementing I here and we'll swap these two. So that will become 75 and it will become 85. Okay, so after the first partition, the array looks like this. So this is our pivot element. Okay, 75. All the elements less than this pivot are lesser than this pivot, and all the elements on the right hand side of this pivot are greater than this pivot. Okay, so now our array is divided. Okay, so you have understood how this divide and conquer method works. Okay, so our array is divided in two parts and this element is fixed. Okay, now we have to further work on both the hubs. Okay, the left hand side on the or the right hand side. Okay, now we can see the left hand side is already kind of sorted. Okay, so if you devise the same process by picking this element as a pivot, you will again get these three numbers on the left hand side of the pivot, and you will get ultimately the sorted array. On the right hand side, if I get this element as pivot, so after sorting it will become 85 and 95. Okay, this way an array can be sorted using the quicksort. Okay, so now let's look at the code and how to implement quicksort. Okay, so now look at this code. So this is how quicksort method is called. So this is our quicksort method. Okay, so this takes an array as an argument and the low and high pointer. Okay, so I denote it at L and H respectively. Okay, so now it will first check. So this is the sanity check, L less than H. L is greater than H, so this is not a valid input. So this is just a sanity check. And now this is the main step, P equal to partition array L and H. Okay, so we pass this partition method the argument as in the whole array along with low and high pointer. Okay, so now what partition returns? Partition returns the index of the pivot element that was fixed inside the array. So in our case 75 was fixed in this position. So this partition method will return the index of this point. Okay, after I got this P, we are very much sure that the pivot element is already at its correct position, right? This is clear. Now we need to sort the left hub and we need to sort the right hub. So this is how divide and conquer works. This same strategy is called here. So quicksort array, left array and low pointer up to P minus 1, which means up to this point. This is low and this is P minus 1. We take this portion into the quicksort again recursively, and we take this portion again into the next quicksort array P plus 1 up to high. Okay, so this is how this quicksort works. So now let's look at the partition works. This you have already looked at this, though I just wrote it down. So partition will take this element as pivot. So you can also say the partition P can be pointing to array of L also. Okay, so there are a lot of different strategies to define what is be the pivot element. So in our case, we define pivot will be the array of high. Okay, so now we run a loop from low point to up to that high point, and we check if array of j less than P, will swap array of I and array of j. Okay, and after all the steps are happened, we need to fix this pivot element to its correct position. So how can I do that? Again the same procedure. We swap array of I plus 1 with array of h. Okay, array of h was initially the pivot element. We'll swap this pivot element to its correct position. Okay, now we'll return the index of I plus 1, which means we are sure that this index is the pivot element, which means this one p, and p is at its correct position. Okay, so this is how Quicksort works. Okay, so now let's look at the time complexity of Quicksort. Okay, so now look at this array, right? So if we choose pivot as this element, so array is basically already sorted. So before delving into Quicksort, we don't know whether the array is sorted or not. So in this case, we'll choose this one as a pivot element, and this pivot element will do what? Will divide the array in two hubs. But in this case, the division will happen in such a way that all these elements will remain in the left hub and pivot will remain in the right hub. So all the n-1 elements, if array contains L element, will remain on one side and only one element will remain other side. So in this case, what will be our recurrence relation? T of n will be equal to T of n-1 plus T of 1 plus order of n. So why T-1? Because it divides the array into one half which contains n-1 element and the other half contains one element. So this is a constant time because T of 1 contains just one element, so it is already sorted. So these just take constant time, so we can ignore this term. So order of n denotes the time taken by the partition method. So in each step, the entire partition method will take order of n because it needs to look all the elements in the array. Okay, so whatever the partition it divides, in each level the partition method will always take order of n. Okay, so what will be the solution of this? If we further divide it as T of n-2 plus order of n-1 plus order of n, so this will continue up to T of 1 plus these terms will look like 1 plus 2 plus 3 up to n. Okay, so what will be the value? N into n plus 1 divided by 2, which means order of n square. So the worst case time complexity as opposed to our merge sort algorithm, as you already know, the merge sort will anyway requires order of n log n time complexity, but the Quicksort, the worst case time complexity of Quicksort is order of n square. So this is a big disadvantage of Quicksort. So there are many kind of remedies. I'll give all the links to the description. You can check out how to overcome this process. But this is not the average time complexity. Okay, so let's look at this. How the average time complexity of Quicksort can be determined. Okay, so if we divide somehow the array into almost two equal parts, it will contain n by 2, it will contain n by 2. So further division will again contain n by 4, n by 4, n by 4 and n by 4. Okay, so this all the levels will require order of n times. This requires order of n, this requires order of n, and this requires order of n. Okay, why order of n? Because the partition method in this case needs to check all the elements in an array. Okay, so that requires order of n time. Now partition method in this step will require checking all n by 2 elements plus checking this n by 2 elements also for this partition method. Okay, so this partition method will require n by 2 and it requires n by 2. So the overall complexity will be remaining same, order of n in every step. Okay, in this case it requires n by 4, in this case it requires n by 4. So the total time complexity at each level will be order of n. Okay, now a question is how many levels will be there. So as we have already seen in our binary search method, so this will take almost, okay, so n will be going to n by 2, then n by 2 square, then up to n by 2 power k. So when it will stop? When n by 2 power k equal to 1, which means k equal to log of n base 2, right? So we are very much sure that we have total log of n levels in this case. Okay, so that will recur, and each level will require order of n times. So on average it will require order of n log n time complexity. Okay, so this is the average case time complexity of Quicksort. So hope you find this video useful for understanding Quicksort, how Quicksort works, how the code of this Quicksort works, and what will be the time complexity of Quicksort. Okay, so if you like this video, please give a like and let me know in the comment section if you have any questions or suggestion regarding this video. Okay, and also please do subscribe to my channel for more contents regarding placement and interview preparation. I'll be posting frequent videos into my YouTube channel for more contents regarding this. Okay, feel free to subscribe. Stay tuned to my channel. I'll see you in the next video. Till then, take care, stay happy, and goodbye.